Alright, this is 6.3. I decided to do a video on this one because it was a bit of a harder unit. We're going to be working through some practice problems, and we're joined by Fernando and Jaden. Say hi, guys.
Hi guys. Hi guys.
Hi.
Alright, let's
Hi.
start with this one.
Hi guys.
So, you remember,
Hi.
are you ready?
Yeah.
You remember
No.
that the limit as n approaches infinity of a summation like this
Mm-hmm.
from k equals 1 to n of at first our delta x, or our change in x, is b minus a over n times f of our a plus our delta x, b minus a over n times k. And this is just our height, this is our width. And that's equal to the integral from a to b of f of x dx, right? And then in this case, f of x is this part, and then dx is just our change in x. That's why there's the dx there with respect to x. Anyways, let's start by working through this question. We first see our pi over n, that's our change in x, so we can relate these two together. So I'm just going to go ahead and write that. B minus a over n equals pi over n. And we know the integral's lower limit is 0, so we know that a equals 0. I'm just going to write that. So b minus
So B
0
equals pi.
over n, yes, equals pi over n. So therefore, we multiply both sides by n, we get b equals pi. So I'm going to start writing the integral now. We know that our lower limit is 0, and we know our upper limit is pi. So we have 0, and we have pi on top. Right? Alright, so now we're gonna find our f of x. So we know that f of this is equal to our f of x, is equal to this. So I'm going to write that out right here. So we have cosine of pi over n times
Wait,
k.
chat. Okay, what notation is
Alonzo, we're
this?
recording a video. Equals
Oh, my bad.
f of a plus b minus a over n times k. Alright, and then we know what our b value is, we know what our a value is. We already solved for those, so I'm just going to write those out. So cosine of pi over n times k equals f of a is 0, so 0, plus b is pi minus 0, over n times k is equal to that. And then just to simplify, we get cosine of pi over
When
n
all the zeros
times
cancel
k
out,
is equal to,
does that mean F is equal to cosine?
yes, and we see. So this is just saying that when we plug pi over n times k into f of x, we get cosine of pi over n times k. Therefore, we can see that f of x is equal to cosine x. And we'll do more problems later where it's not super obvious like that one. But for that one, it was pretty obvious. So we have cosine x dx, and that's our final answer.
Yeah, good job. Good job, Eric.
Alright,
Y'all guys.
Next question. Next question.
we're gonna go to our next
Next
question.
question.
More. Alright, this time,
Oh, guys, look. It says lower limit equals -3. Take a note of that.
so
That means a equals -3.
yes. And
So 5 plus 3 over n. Or, no, sorry. B plus 3 over n equals 5 over n.
hold on, I'm just gonna copy this.
What could that mean, guys?
That means, so b over a, b minus a over n is this part right here, right, Fernando? So b minus a over n equals 5 over n. And then we know that a is equal to -3. So b plus 3 equals 5.
Equals 5
So
over n.
b equals
Alonzo,
8.
what do you think of this?
That means our lower limit of the integral is -3, and our upper limit is 8. Alright, next, we know that this part is going to be equal to f of this part. So now, I'm just going to write that out.
Wait, Eric,
What?
you made a mistake.
What
I
was
think.
my mistake?
B plus 3 equals 5. Isn't it B equals 2?
Yes.
Yeah, you're right.
Because it's
I don't know
negative
So
why.
we
of
have to be
negative.
very careful. We need to be very careful. Simple
This
mistakes.
Proves to always check your answers, even the
Exactly.
simple calculations.
Alright, and then this is equal to f of, and then I'm just gonna plug them in right now. Negative 3 plus b plus 3. Yeah, because it's b plus 3, and we know b is 2, so 5 over n times k, right?
Mm-hmm.
Yes.
So from here we can see it again. F of x is just what?
Cube root
Cube
X.
root x.
So our answer
Oh my
is
gosh.
root of x
Look at that.
dx.
Ooh.
That is crazy.
Alright,
Oh my
last one
god.
where we're converting from summation to integral. We have this one right here. And I'm just gonna take this and copy this
And
over.
look, lower limit equals 6, guys. That means a equals 6.
Yes, a equals 6. Equals 6. So that means that b minus 6 over n is equal to this part right here, 9 over n. So b minus 6 equals 9. So what does b equal?
15. Yo.
b is
That's
equal to 15. So
crazy.
I'm going to start off the integral from 6 to 15, right? Now the second part. 1 over 6 plus 9k over n squared. That's equal to f of a plus, I'm going to just do it right here. A is 6, so we have 6 plus 15 minus 6 is 9. So 9 over n k, right? That makes
Mm-hmm.
sense?
Yes.
Yeah.
Here's my trick. Right here.
Oh.
I
So
look
look,
for where
Eric.
this part is over here, and
and
I can
just
see it's
replace it
right.
with X, right?
Yes, and replace it
Eric.
with x.
That is
So
actually
f of
insane.
x equals 1 over x
1 over
squared.
x squared.
So then it's
Oh my
1
gosh.
over x squared dx. And that's our final answer. Alright, are you ready to convert from integral notation to summation notation now? The other way
Yeah.
around.
Yeah.
Okay.
Alright, so now we have to go the other way around. Let me just copy this over here.
So do you take the function first?
Yes, we're gonna take the. Alright, first let's just write out how we normally start our limits. Our summation notation. Limit as n approaches infinity of the summation from k equals 1 to n times. Alright, now we need to find out delta x. Delta x is equal to b minus a over n, right?
Well,
That's going to be our width of our rectangle.
b is 3, a is
And then
negative
A
3.
is
So
negative.
3 plus
Therefore,
3
change
over
of
n.
x equals 6 over n.
So
Oh my
we're going to start it
god.
off with 6 over n. That is
That
this
is
part right here.
crazy.
Now we need to
Okay, and
get
now,
this part right here, right?
yep.
So,
And
yes, Jaden?
f of x is
X squared,
x
right?
squared, right?
Yeah,
So you can just
Yo.
plug in all the b's and a's.
yes. So,
A
and we
plus
know
Split
it.
it squared.
We know a plus b
a plus
minus
yes
a over n k.
times k.
That's equal
Yes.
to a plus b minus a over n times k squared.
Yes.
And now we know what a and b is, right? We know a, this is
Yeah.
a,
A
and
is
this
negative
is
3,
b.
B is 3. Oh
Oh wait,
my god.
I swapped them. This is b, this is a. So that means we have negative 3 plus 3 plus 3 over n times k squared, right? And we can simplify this a bit more. Plus 6 over n k, I'm going to put the k in the numerator, squared. So that goes right here. We just slot that in. Negative 3 plus 6k over n, and then everything
Yo,
squared.
Is that
and
it?
that's our
that is
final answer.
insane.
Alright, do you want to do more? Let's do two more questions of that, and then we'll move on.
All
Our
right, now
next
do the integral or the indefinite integral of 1 over x to the fifth plus 1 dx.
That's unit 1. That's unit 6.7. Not yet. Anyways.
Oh, okay.
Okay, wait. Let me copy this over. I think we're losing parts as I copy. Anyways, we have this. So b. What's our b value? It is 5, and our a value is 2 because those are the boundaries, right? So we're gonna start off our summation notation with the limit as n approaches infinity of our summation from k equals 1 to n. And now b minus a over n. We know it's 5 minus 2 over n, which is what?
3.
3 over n. So that means that we have 3 over n times, now we gotta find our f of this. So we know that f of x is equal to 1 over x, right? So now we find f, and I'm just gonna plug it in right here. A is 2 plus 5 minus 2 is 3 over n. So I'm gonna just write the k in the numerator, right? And then we plug this into x, so we get 1 over 2 plus 3k over n. Does that make sense?
Yes.
So we have 1 over 2 plus.
Because width times length is the area of a rectangle.
And this is our answer.
Our width is 3 over n. Our length is 1 over 2 plus 3k over n. Isn't that insane?
Yes, that is correct. Alright,
That's so cool.
last question. We got this right here. Alright, you ready? Oh. Alright, you ready? So, first, we know that our b value is equal to 7 and our a value is equal to 0. That means we won't have to be worrying about our a value because it's just 0. So the limit as n approaches infinity of our summation from k equals 1 to n of our delta x, b minus a over n, that's 7 over n, right? Because 7 minus 0 is just 7. So 7 over n times, now we have f of x is equal to the square root of x. That means f of, and I'm going to plug everything in, a is 0, so we just have 7 over n times k at the top. 7 over n times k at the top, and that's equal to the square root of 7k over n. So times the square root of 7k over n. And that's our final answer. Alright, are you guys good with converting between the two? Are you ready to move on?
Listen, guys,
Yes.
just a quick note.
Time to
This
move
is
on.
super important concept, super important topic. You need to know what's going on, how it works, and how summation relates to integral, okay? It's super important, alright?
Yes, an integral is adding little bits. So now, we're going to do this question. You ready? It's a little bit more tricky. But first, right away, this is our width of our rectangle, right? Does that make sense?
Yes.
So
1
that
over
means
n
delta
equals
x
b minus a over n.
is equal. Oh wait, there's multiple choice. Hold on. Let me go back. Let me get the multiple choice. Alright. Oh. Alright. So delta x is our 1 over n, right? Delta x equals 1 over n. So that means 1 over n equals b minus a over n, right? So
Yes.
b minus a has to equal 1. So we can already rule out anywhere where b minus a doesn't equal 1. We already got rid of one solution. Because 2 minus 0 is not 1. Right?
Yeah.
Alright, let's keep going. I'm going to write this in summation notation first before we do anything. So the limit as n approaches infinity of the summation from k equals 1 to n, and our first term is our width is 1 over n, times our length. Now, what's the difference between this one and this one? What's the difference, Fernando?
Huh? The
What's
numerator is increasing.
Yes. So if this is
Oh my gosh.
a, like think of it as a sequence, right? If this is a of 1 and this is a of 2, the value that changes is this is increasing by 1, right?
Yes.
So if we have our summation, that's just our k value. So
no.
we just have 1 plus k over n. Does that make sense?
Yes.
Alright, so now we need to convert this to integral notation. Okay? Alright? So we can see that nothing is being added to this. Right? But guess what? Guess what?
What?
We can't, that doesn't mean our a value is 0, right?
Oh yeah.
So let's start. Okay, we already found our delta x. Let's find our f of x. So f of a plus b minus a over n times k, that should be equal to this part.
Oh, Eric, I see it.
1 plus k over n.
That's
Right?
crazy.
Alright, so now we know our a value, or we don't know our a value and we don't know our b value, but we know that b of minus a should be equal to 1, right?
Yes.
So using that, we could try to find, we know that this is k over n, right? And that's e to the 1 plus k over n, right? Now we don't know our a value, right? But we know that when you plug this into the function, you get this. So where do we see something that looks a lot like this? Where do we see it in the function?
In the power of e.
Yes, right here. So we know that a plus k over n is equal to 1 plus k over n. So what does that tell us?
The function
First of all, what does that tell us?
x.
Yes, a is
And
equal
a
to 1.
equals
And
1.
we just replaced where we found it with x, right? So we get f of x equals e to the x. So now we know that a is equal to 1, b is equal to... Do we have b? Okay, well we know b minus 1.
We can solve for b.
We know that a is 1, so b minus 1.
b equals 2.
B equals 2. So it already can't be this one, and we know that our function is e to the x, so it must be b.
Wow.
Oh my goodness.
All
That's
right.
astonishing.
Isn't
Wow.
that crazy?
Oh my goodness.
All right.
Yes.
You ready?
That's so
we
awesome.
have one more question that we're gonna do today.
Is this the
Yes.
last question?
The last question. Oh wait, that shows the answer. Hold on.
No, I saw the
No.
answer.
It's okay. It's
How
okay.
could you?
Here's the question.
It's
Okay.
the same one.
The same one.
Which of the following expressions is equal to the limit as n?
Eric, it's the
Oh,
same
that's
one.
The same one. Hold on.
Same question.
Technical difficulties.
Alonzo.
We'll do this one. Alright. The expression 1/5. So now, this is our width, right?
Yes.
Guess what? We don't care. We don't care what that number is because this is a definite integral with set rectangles. This is the important thing to note here is this is a Riemann sum approximation. This is not going from summation notation to integral notation. We're looking at a Riemann sum. It could be a left Riemann sum or it could be a right Riemann sum, right? And this is what the Riemann sum is showing. So we know that our height at the first thing is ln of 2 plus 1/5, and the second thing is ln 2 plus 1/5, right? So we can use what we did before. We got f of a plus b minus a over n equals ln of 2
Do we need to include k or no? No, we don't. Never mind.
Well, here's the thing, right, Fernando? Every time we go 1 up, right, we're increasing by 1,
Yeah,
right?
I realized.
So, and we know that the end boundary is 5, because we only go up to 5/5.
Yeah.
So we know, so what does that tell us?
B is 5.
Okay, not necessarily though.
Oh wait,
because-
yeah, no. Alright, tell me. I don't know.
Okay, so first let's try to figure out our a value. But we can, so we can see that there's a 2 being added onto all of these, right?
Oh,
So that means
never
the
mind.
integral
I
probably
see.
most likely starts at 2. So we can already rule out answer choice B and answer choice E. Does that make sense?
Yes.
And we don't have any scalars, or we don't have anything outside the summation. We have this 1/5, but that's our delta x, right? So we can rule out answer choice C as well. Alright, so now how are we going to decide between answer choice A and answer choice D? Well, let's look at what we have here. We have A, which we know is 2, and we have B minus A over n. B minus A, we know that it's increasing by 1 each time, right? So B minus A must be equal to 1. And we know that there's 5 rectangles, so n must be equal to 5. Does that make sense?
Yeah.
There's 5 total rectangles. This is not, n is not approaching infinity in this case. N is 5, because there's 5 different subdivisions. Does that make sense?
Yes. There's 5 rectangles.
And we know we're starting at 1. So we have 2 plus, and B minus A should be equal to 5, and we know A is 2, right? Or B minus A should be equal to 1, so B minus A equals 1, and we know A is 2, so B minus 2, B plus 2 equals 1, right? So that means B is equal to 3. Does that make sense?
No. Why does B equal 3? If you subtract 2 on both sides.
No, B plus 2 has to be equal to 1.
Yeah. B plus 2 equals 1. You minus 2 on both sides.
Okay, wait.
You get B equals minus 1.
B minus 2.
Yeah, now that makes sense.
Okay, sorry. So that means B is equal to 3 and A is equal to 2. Okay, both of our answer choices say that. So f of 2 over 3 minus 1 is 2. Or 3 minus 2 is 1. And then we know our n is 5. And that's equal to ln of the same thing. So what is our f of
wow.
So what is the function?
ln.
What is it?
Just ln x?
ln x.
x.
Yes, that's the answer.
No x over 5?
No x over 5. Because 5 is our subdivisions. That's why we're dividing by 5. Does that make sense? Are you good on this unit?
Yes, teacher
Yeah.
Eric.
Alright, that's the end of the video.